expectation. The expectation of a discrete random variable x is denoted by mu x or e of x, and it is defined as the sum of x times p of x, where the sum varies over all values of x. It can also be written as the sum x of s times p of s, where s goes over the elements of the sample space S. And the sum can also be written as the sum xi times p of xi, where for each I, xi is a value of x. Besides expectation, mu x or e of x is also known as mean and expected value. Once again, when the context is clear, we will skip the subscript x on mu. There are three important properties of expectation. The expectation of a constant random variable c is the same as c. The expectation of a constant times x is the constant times the expectation of x for any constant c. And 3, the expectation of x plus y is the same as the expectation of x plus the expectation of y. If y is a function of x, g of x, then the expectation of y the expectation of g of x is the sum of g of xi times p of xi, where I goes over all possible values. For example, the expectation of e to the x is equal to the summation e to the x times p of x, where the sum goes over all values of x. So let me explain this concept by two examples. Let x be the outcome from a roll of a fair die. So the probability of 1 is the same as the probability of 2, the probability of 3, probability of 4, probability of 5 and 6. They're all the same, which is they are all equal to 1/6 because it's a fair die. The expectation of x then is the summation of n times p of n, where n goes from 1 to 6. And so basically we multiply each value of x by its probability and then sum them together. So it's 1 times p of 1 plus 2 times p of 2 plus 3 times p of 3 plus 4 times p of 4 plus 5 times p of 5 plus 6 times p of 6. And we know that each probability in the sum is 1/6, so I get 1/6 plus 2 times 1/6 plus 3 times 1/6 plus 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6, 1/6, which is the same as 21/6, which is 7/2. Let's look at another example. Let's say I have a random variable x which has only 3 values, -1, 0 and 1. The probability of -1 is 0.2, the probability that x is 0 is 0.5, that the probability that x is 1 is 0.3. Okay, so what's the expectation of x squared then? Well, the expectation of x squared then is the following. So we replace x, so it'll be -1 to the power 2 times the probability that x is 1 plus 0 squared times the probability that x is 0 plus 1 squared times the probability that x is 1. So what we get is 1 times p of this should have been p of -1. P of -1 is 0.2 plus 0 plus 1 times p of 1 is 0.3. So altogether we get 0.5. Now if y denotes x squared, then notice that the probability that y is 1 is the same as the probability. The only way you can get y to be 1 is when x is 1 or x is negative 1, which is the same as the probability that x is 1 plus the probability that x is negative 1, which is 0.3 plus 0.2, which would be equal to 0.5. And also, what's the probability that y is 0? Well, it is the probability that x is 0. That's the only way you will get y equal to 0, and the probability that x is 0 is 0.5. So if I calculate the expectation of y, if x has 3 values, negative 1, 0, and 1, then y has only 2 values, 0 or 1. So the expectation of y would be 0 times the probability of 0 plus 1 times the probability of 1, that y is 1. Those are the only 2 values of y. And the first term is 0, and the second term would be basically p of 1, but the p of 1 is the same as 0.5 as we have seen above. Okay, so I calculated expected value y, but of course we also calculated the expected value y right here by directly using the values of x. Here we calculated the probabilities of the values of y first, and then we calculated the expectation of y. Alright, so in the next video we will define moments and go over a few more examples.